All right, Algebra 2, Lesson 84. You're doing great. Stick with me. Let's do this.
Flack math! Give me some math and I'll give you some flack. Flack math!
All right, Lesson 84. Here's what we're doing today. We are gonna solve rational equations. Okay, rational is just a fancy word for fraction. Okay, so rational expressions in algebra language are just fractions. That's what rational means. So whenever you have fractions, you always have to be conscious of the fraction breaker. You know, what will break a fraction is if you end up with a zero in the denominator. When you have a solution that will break a fraction, it's called an extraneous solution. I know, it's weird. All right, so let's just start with example 1. There's an A and B, so this is 1A. So here's what 1A says. 30 over x squared minus 25 equals 3 over x minus 5. Now, there are a couple different ways to solve this, but I'm gonna show you all of them, okay? The first way is just cross multiplication. So since these fractions are equal, that means their cross products are equal. So 3 times x squared minus 25 has to equal 30 times x minus 5. Okay, so let's write that out. 3 times x squared minus 25 has to equal this cross product, which is 30 times x minus 5. All right, let's figure that out. Distribute that out, you get 3x squared minus 75 equals 30x minus 150, okay? Let's get everything on one side with 0 on the other. So you end up with 3x squared minus 30x. And let's see, you bring that 150 over here, it becomes a positive 150, so you end up with 75 equals 0. Okay, let's see if we can solve this by factoring. First step of factoring, get rid of any greatest common factor. Let's take a 3 out. And actually, yeah, let's take a 3 out. So you get x squared minus 10x plus 25. Okay, now if you just divide by 3, look what happens. If you divide by 3, those cancel and you're left with 0. So really, when you can factor out a greatest common factor, when you're solving by factoring, you can just ignore that greatest common factor. Just get rid of it. So here's our equation. X squared minus 10x plus 25 equals 0. Solve by factoring. This is a square trinomial. So x minus 5 equals 0. So x has to be 5. Okay, so now when you plug this back in to check to see if it works, what happens? You end up with undefined fractions, right? You can't divide by 0. So this is technically a solution, but we call it an extraneous solution, okay? It's a little different, but that's what we have to call it because that will break that equation. We don't want to break it. We just got it. It's new. All right, let's try 1b. Here's what 1b looks like. 9 over 5 minus x equals x over x minus 5. Okay, cross multiply. Let's see, x times 5 minus x is, let's see, 5x minus x squared. Let's do the green here. So that's 9 times x minus 5, so that's 9x minus 45. Let's get everything on one side with 0 on the other side. Let's put everything on the side that's going to make your x squared term positive. So let's move everything over to the right here. Okay, so 0 equals positive x squared. And then when you get rid of that 5x, you end up with a 4x minus 45. All right, let's see if we can factor this. We can. X plus 9, x minus 5. So x's are negative 9 and positive 5. Okay? When you plug these in, negative 9 won't break that equation. Look, you plug in a negative 9, you end up with a positive 14 on this side, and you end up with a negative 14 on this side. That doesn't break the equation. So negative 9 is a solution, but 5 will break that equation. 5 minus 5 is 0, and 5 minus 5 is 0. So we're just going to cross that out. So negative 9 is technically our only real solution because 5 is considered that extraneous solution. All right, so that's one way to solve these rational equations by just using cross multiply. All right, let's try another way. Here is example 2b. And if you're looking in your book, this is a typo. It says 4x, but it's actually 10x over x minus 9 equals 15. Okay. The other way to do this, since you could do cross multiplication, whatever, or you could just multiply by the common denominator. Well, there's only one denominator, it's x minus 9. So let's multiply everything times x minus 9. Okay? When that happens over here, that cancels and you're left with 10x. And then we're just going to distribute that, 15x minus 135. Okay? So get our x's by itself. Let's see, subtract 10x. Let's bring this guy over here. And we get 5x over here. And we get a positive 135 over here. Divide by 5 and x equals 27. All right, let's plug in 27 here. Does it break that? Nope, it doesn't break it. So this is a good solution. Let's test it, make sure it works. 10 times 27 is 270. Divided by 27 minus 9 is 18. 270 divided by 18 is 15. It works. Okay, let's try 2b, or not 2b. I guess that is 2b. All right, that was supposed to be 2a, sorry, 2a. All right, here's 2b. 8 over x plus 2 equals x. All right, let's multiply by the only denominator we see, which is x. Okay, so we're going to distribute that x to both of those. Let's just write it out so it's not confusing. So we're distributing the x to the 8 over x and distributing the x to the 2. And that on this side, we'll just simplify that. That's x squared. So let's rewrite this. The x's cancel and you're left with 8 plus 2x equals x squared. Let's bring all this stuff over here. So we get 0 equals x squared minus 2x minus 8. Let's try to factor that. That does factor. X minus 4, x plus 2. So x is 4 or negative 2. Now, plug those in. Does that break anything? Nope. The only thing that'll break this fraction up here is a 0. So none of these are 0. So here's our two solutions. You can check them to see if they work, and they do. So 8 divided by 4 is 2, plus 2 is that 4. 8 divided by negative 2 is negative 4, plus 2 is that negative 2. So they both work. All right, example 3. All right, there's no A and B, so it's one big crazy one. This is the third way to solve for rational equations, and this is just finding a common denominator. So x plus 5 over x plus 3 plus 28 over x squared plus 8x plus 15 all equals 4. Okay, so your common denominator, these two, well, you need to factor this out so you can see the common denominator. So I'm going to factor this out. When in doubt, factor out. So that's just x plus 3, x plus 5, okay? So this guy almost looks like that. It just needs like an x plus 5. So let's multiply both the top and bottom by x plus 5, and now they look the same, okay? So now we can add these two together. So this is just, well, let's FOIL this out first. So we get x squared plus 10x plus 25 plus 28 all over that same denominator, because since we have the same denominator, we can just add the numerators, and that all equals 4. All right, so now I've got a denominator that I can multiply both sides by, and it'll get rid of it. So let's do that. So let's get rid of our only denominator, which is this x plus 3, x plus 5. Whatever you do to one side, do to the other. X plus 3, x plus 5. Okay? So then these would cancel on this side, right? And I'm left with this x squared plus 10x plus, let's add these two together to get 53 equals, let's multiply this out, 4 times, let's see, x squared plus 8x plus 15. So now I'm going to distribute that. So I get x squared plus 10x plus 53 equals 4x squared plus 32x plus 60. All right, let's get everything on one side. So I'm going to bring everything over to the right side because that would keep that x squared positive. So let's get all of this over there. So I'm left with 0 here. Combine the x squared, you get 3x squared. Combine the x's, you get 22x. Combine the constants and you get 7. Okay, so let's just use our quadratic formula. Remember, our quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. Well, what's our a, b, and c? Remember, a is your coefficient for your x squared term, b is your coefficient for your x term, and c is your constant. So let's plug it in. Or you can use a handy dandy quadratic formula calculator. So I just found this, it's calculatorsoup.com. I'll leave a link in the details here, but it's nice because it gives you just a quadratic formula calculator. So I'm just gonna plug in my a, which is 3, my b, which is 22, and my c, which is 7, and it's working. And I get x equals negative 1/3 and negative 7. Okay, so x equals negative 1/3 and negative 7. If I plug in either of these into my denominators, it's not gonna mess anything up. So these are my solutions. Boom. That's not too bad. Okay, example 4 is kind of you can calculate distance, rate, and time this way. It's kind of a fun little application if you're into that sort of thing. But that's it, basically, for lesson 84. Well done, you did it. Good job.
Flack math! Give me some math and I'll give you some flack.